Okay, so we'll start again. So again, if you have some question on what we did before, even later, don't hesitate to ask. So we'll talk about standards now. So in the not the afternoon, but before lunch, we'll have to look at standards, how to use charts mainly, and how to calibrate the scanner. So there are three main guidelines. I mean, two are well known because they are a little bit older. You have Metamorphose, maybe you heard about that, from Netherlands. You have FATG from the US. And now you have an ISO standard. Okay, so Metamorphose is so from a project, digitalization project in the Netherlands. So because it's from this project, there are some specific settings, like it is made for 300 dpi mainly. And they split the document in three parts. You have, for Metamorphose alone, full we call, or complete, I don't know. You have a document having a high density. That means density more than 1.5. 1.5 is this one. So usually notebooks, it can be photograph, paintings, artwork, can have a high density like this. If you are scanning book, manuscript, usually your density will not go higher than 1.5, so you can apply Metamorphose Light. And you have extra light for newspaper or documents that can be scanned in grayscale, for example. And let's say you want to scan books, you apply Metamorphose Light, then you have a threshold, you make the test, it is good or not. There are not several levels, there is only one level. Your scanner or your test is okay or not. And that gives some value to Metamorphose because if you are a service bureau, you say, I'm able to scan according to Metamorphose, it's good, especially if the competitor cannot. Same for a scanner. If you say my scanner is Metamorphose compliant, it's good if the others are not compliant. You will see for FATG there are several levels, so you will always be FATG compliant, maybe only 1 star instead of 2 or 3, but always compliant. All the units are based on human vision, so that means LAB units. And because of that, the color space is ECI RGB, which has a L-star curve for the gamma correction. And again, it's made mainly for 300 dpi, even if you can apply it at 400 dpi. So this is just a sum up. So you find the criteria. So the tonal response, you have to be within a range of 2 L-star level. That means about 5 RGB level. The color accuracy has to be, so for Metamorphose, it has to be, the average level has to be lower than 4, and the maximum has to be lower than 10. And for this, we will use the 76 formula, the one we saw at the beginning. When you check Metamorphose Light, you can have only, you can go up to 5 for delta E, for the average delta E, and 18 for the max 1. Sampling efficiency, you see it's 85%. So it's not 100, 85 is still okay. Noise level is 4, distortion is 2%. Lighting uniformity depends on the scanning area. So for A3, we take A3 because the chart we will use is A3. Is about 3L, so that means about 8 RGB level. And there is a criterion we didn't talk about. It's a color misregistration. Is when you scan, for example, a black text on a white paper, you can have a shift between the 3 channels, red, green, and blue. And it's allowed to have half a pixel for Metamorphose Light and a third of a pixel for Metamorphose. So it's just a sum up. We'll have a look rapidly at the whole PDF. How does it work? When they have created Metamorphose, it was in 2007. They decided to create a chart going with Metamorphose to check that. Because instead of using this chart for the color, this one for the grayscale, another one for resolution, it is easier to have only one. So they have created this one. So it's a UTT chart for universal test target. And on that, you have some grayscale. You have some resolution charts. So the one with the line and the one with the edges. You have some color patches. You have some white line and gray line to check the lighting uniformity. You can also check the lighting uniformity on the checkerboard. And on this checkerboard, you can check the geometry, the distortion. So you have everything on it. But after some time, they realized that there was an issue with color patches of this chart because they were very sensitive to the light. Because it's printed, this chart is printed with an inkjet, and it's sensitive to the lighting spectrum. So the result is not consistent. So they prefer to check the color using the color checker SG, which is this one. So how to check this? You check maybe first the color, and the color is okay, you check the UTT, and when everything is okay, you can go scanning. And but you are supposed to check every day or even per shift, that in the morning and in the afternoon. So in Holland, in the morning they come, they scan the chart. If the result is good, they can scan. If not, they have to fix it. And the same in the afternoon. So it's quite heavy, it's quite difficult. But if you select the right level and if your scanner is okay, you should be able to work like this. I mean, at the National Archives, there are 15 scanners like this in a room, and they are applying metamorphose every day for several years. So it's possible. Not easy, but it's possible. Okay. And when they check in the morning, in the afternoon, they just use a UTT. As long as the color was okay, they look what was the result on these patches, on the UTT. And if the result is about the same, that means it doesn't change so much. Okay, so I can show you a little bit PowerPoint. Okay, this is. So it's created by Anne van der Molen, so from the National Library. I will try to enlarge. Okay, and I will not go through all that. You know, the last version is 2012. What is interesting, I mean, it's a full PDF, is this table here. Yeah. So here you have the full specification. So you can see, for example, you have to apply this color space, ECI RGB. For metamorphose light, it is also allowed to use Adobe. Okay. You could use 16-bit, but 8-bit is okay. So this is, yeah, the main difference between metamorphose light and metamorphose is that you will check for metamorphose light up to L star 20, that is a density of 1.5. And for metamorphose, you will go up to the maximum density of the chart, which is about 2 to 3 on this one.
So it wouldn't be good to apply metamorphose to regular books or manuscripts because the density would be too high. So it's really better to use metamorphose light on these documents.
It should be enough. If you check here, there is nearly no difference, except on the density. You know, we're checking. All these numbers are the same between metamorphose and metamorphose light. The only difference, there is a slight difference here, the color mist registration, and another difference in the color accuracy. I mean, this may be a problem sometime, but Except that there is no main difference between metamorphose and metamorphose light.
So you could use metamorphose for regular books.
Yeah, of course. Yeah, you can. Yeah, of course, you can do. But you will do it, but you will check the density, the high density you will not have in your document. So you may spend a lot of time, adjusting to have a correct value for the high density, and you will not get this value in the document. So it could be a waste of time also sometimes. So that's why. But you will see all, even if the detail here between metamorphose light and metamorphose, there is not, the numbers are the same except this. What else? Yeah, when you check the tonal response, you will also check the color. So this is the difference which is allowed on the luminance on the gray level. But you also have to make sure that the color of the gray patch is okay. It is a gray, must be gray, and not green or red or something. Okay. What is interesting in noise? Here you can see the lighting uniformity. For A3 you have 3L allowed. But for A2, you can have 4L, and if you go on the next page, you will see for A0, for example, it can go up to 6L, which is quite large. But A0 is a large format, so it's difficult to send the lighting on that, especially with a matrix camera, by the way. And all is made for 300 dpi. Okay. This version is from 2012. There will be a new version next year. And maybe they will change that, because this, depending on the technology at this time, you saw, for example, if you have more than A2, you're supposed to scan 150 dpi, which is not a lot. I mean, A2 now we can scan at 600 or more. So there are some small limitations like this. This is efficiency. You have the maximum modulation, the fact that we should not apply some sharpening, so it is checked here. Geometric distortion, and artifact is just say none, you have to check by height, and you have to have no artifact. Okay, and that's it. And this is, not really part of metamorphose, just easy to use. It's on the UTT. These are the value you should get for all the gray patches, depending if you are using ECI RGB or Adobe 98. So for example, if you look at the black patch, blackest one, it should be 13 if you use ECI RGB, which has a L-star curve, and it is 24, so quite different if you use Adobe 98. So here you find what we said at the beginning. Depending on the gamma correction, the level are completely different. And you have the same for the Kodak grayscale, which is the old one, and the same for the Color Checker SG. You have all the luminance, the level you should get on the black patch here. Can be 17 or 28, depending on your color space. And then you have some formula, some other explanation. If you go to the detail, you have all the detail explained. I will not go through that. I don't know. There are 44 pages. So, okay, just for you to know. And again, there should be a next version, a new version next week. What should change in this new version? They will change this formula here. They will apply the same that we have in ISO for now. That's the main difference. Okay, so again, metamorphose, no big change between metamorphose and metamorphose light, but the fact to check in the high density can make a big difference sometimes. FADG. FADG is from the US, so Library of Congress, NARA, and so and so. They started in 2004, and the last version is 2016. So you have everything on this website. The difference, you have different level allowed for each criteria. So you can say, I want to apply FADGI 4 stars, 3 star, 2 star, or 1 star only. So you will always be FADGI compliant, but not the same level. You have also many kind of documents supported, much more than in Metamorphose. So you have microfilm, paintings, anything, radiograph, and so and so. People from FADGI and Metamorphose are talking together, so they're trying to get a closer specification, use the same unit if possible. So it's going slowly, but it's improving. So now they're using LAB for some units, and they try to have some closer specification. What is very interesting, they want to promote FADGI. I mean, they want everybody, in the US at least, to be able to scan according to FADGI. So for this, they are trying to, they made a software, analysis software, which is free, so that you can use also in Europe, of course. And they are working on a new chart, which will be cheap, they say about $200. So like, this one is about $300, UTT. This one will be about 200 plus free software. That makes quite cheap to check your quality. They make a big effort on that. I mean, they bought the source code from an existing software, and they made their own software from that. So they really want everybody to use that. What else? Yes, they may require 16-bit sometime. And something which is good, the resolution depends on the star level you want to reach. So for books, if you want to scan to get 4 star, you have to scan 400 dpi. If you just want 3 star, you can scan 300 dpi. Okay, it's logical. So here is a sum up. So there are, I can show you also. So this is the 2016 version, and okay, yeah. So the guy responsible for this is Tom Rieger from the Library of Congress, and maybe you heard about Don Williams. It's an expert, color expert also, that work on that. What I want to show you is this. So you have many explanations and so, and then you have one table for precious book with some value for 2 stars, 3 stars, 4 stars. Not 1 star because it's a precious book. You are not supposed to scan low quality such a book. And then you have some value, and you go further, and now you have some other value for standard books. Then you can scan 1 star. And you have this value are about the same, but there may be some difference sometime. And then you have some other value for manuscript, unbound. Then you have some value for general collection, unbound document. And then you have for maps, and so on. So it really depends on what kind of document you have. You have different value to get. And if you check in detail, there are nearly no difference for this one. Of course, it will be really different if I go for photograph, for example. Then you need 600 dpi to get 4 star instead of 400. And if you go for transparency, of course, it's completely different. Then you need another resolution because the document is much smaller. So that makes it is not really possible to say now this scanner is FADGI compliant. You have to say it is compliant for special book, for rare book, but not for negatives, not for photographs, and so on. Okay, so it looks complex like that, but it's quite easy to apply. Let's go back here. So if we want to make just to sum up, so for rare books, you have, so for 3-star you have 300, you need to scan at 300 dpi. For 4-star you need 400 dpi. This is resolution, you know, the scanning efficiency, sampling efficiency. So here you have something different. For 4-star you have to reach 90% efficiency. It was 85 for Metamorphose, so it's a little bit higher, and 80% for 3-star, and you can go down to 70% for 2-star. You remember the sample, which were not so good, I showed at the beginning, it was about 70%, so it was about 3-star, a little bit lower. You have a test also on the MTF50 that is 50% contrast. It has to be within a range. The color accuracy, it's another formula. It's not just the distance in the color space. It's a formula which has been modified because they found out that the 76 formula was not so good. When you check with people, I mean, you ask two people, compare these two images with these two colors, do you see a difference? Yes, no, and so on. So when you make many tests like that, they realize it was not so good. So there is another formula, a little bit more complex. And there is a, so for 4-star, you have to have an average delta E lower than 3, and so on. So the tonal response, so here it's not in L-star, it's an RGB. So you have to be lower than 2 RGB, which is very difficult to reach for 4-star, and 5 level for 3-star, which is about like Metamorphose. The noise, here it's in L-star, so you have some value here. Again, Metamorphose is very close to that, between 2. Lighting uniformity, so it's in percentage, but if you compare Metamorphose, it was in L-star, lighting uniformity. But L can go from 0 to 100. So 1L is 1%. So here, that means this is like Metamorphose, and this is more difficult to reach, only 1%. The color image registration is a little bit like Metamorphose. And here you have the sharpening, which is, so here no overshoot allowed, here a little bit, and here a little bit more. So what is very specific to Faji is that here, about the sampling efficiency, you have to be higher than such a percentage, but you have to get not too much contrast at the maximum frequency. So if we take the MTF curve, usually we were checking the 10% contrast. We have to be higher than 90%, 80%, 85%, and so on. So, by the way, here you see we are in the US, so they are talking directly in dpi. You know, they don't have the millimeter. So, as I say, 400 dpi, and instead of talking about efficiency, they just say, I have 350 dpi for 400. Okay, so let's say for 4-star you have to reach 90%, okay, but you also have to be lower than this point. So the curve has to be within these 2 points, which is difficult to get because sometimes you don't have enough resolution, sometimes you have too much, especially on the whole scanning area. And why do they do that? It's because at this frequency here, when you have, you know, one line which is the same size than 1 pixel, you remember that when the pixel is in front of the line, I can see the lines. When the pixel is between 2 lines, I just see something gray. And if the level here is too high, I will have a big difference between the place in the document when I scan a drawing where I can see the line and where I cannot see these lines. So it will be really visible on the image. So they want to avoid that, I mean, to get it less visible. They want to see the line, but not too much, because it depends on the ratio between the pixel and the line. That's why they've put that. So you don't get this in Metamorphose, you don't get that in ISO also. And that makes it quite difficult to reach. That's what you should get. You know, when you scan something like this, if the pixel is about the size of these dots, you may have something like this. Not exactly, but something similar. So reducing this contrast at half frequency will reduce this effect. It's like, you know, when you scan something, you have some Moiré effect. One solution is to unfocus a little bit. Then you have you don't see the Moiré effect anymore. And then you have the ISO. So it's because people of Metamorphose and Fadji are talking together, and they said, okay, we have two different standards. We would like to have only one with the same unit and for everyone, because Fadji is from the US. They can decide to change what they want when they want. If you want to apply Fadji, and if they change something, you cannot say anything. You are not from the US. In 2012, there was a group found in the ISO to try to build a standard with the same metrics, the same methods and everything. So in this group, you had people from Fadji and Metamorphose, of course. You had some color experts from Rochester Institute of Technology. We were some scanner manufacturers, so we were in this group. There were also some chart manufacturers, because it's part of it, and some national library, I mean the user. And at the beginning we had the USA, Denmark and Norway. And so we built a standard introducing a visual noise. Why visual noise? It's because the noise is more visible when it is at low frequency than high frequency. It's always the same. When you look at the image, zoomed at 100%, you cannot see the detail very well. So visual noise, it is a noise which is measured, but it is weighted depending on its frequency. You will have more weight if it's a low frequency noise than if it is high frequency noise. Okay, there is a new formula for the delta E also, and that's it more or less. And the next step will be transparent document. And the number is this one. This is a document. If you want to, you have to buy it. So the document containing all the information is this one. This is just a glossary, and this is a text describing the best practice, but this one is really one. And yeah, about color accuracy, this is a 76 formula. So just a simple distance in the color space. And this one is a delta E 2000, a much complex formula, we don't mind about this. The idea is just to be closer to the results they get when they make some experiment with people. And in this group, they decided to remove this part from the 2000 formula to get the 2000 SL1 formula. So SL is equal to 1. So you remove all that. Doesn't make a big difference. But okay. And this is a sum up. So you have 3 levels, A, B, and C. So A is the best. And this is so the delta E. You see the numbers are always increasing. So C is much easier to reach than B and easier to reach than A. So if we compare, so you see you have tonal response is easier here. Sampling efficiency 85, 80, 70. The noise also is higher, and the misregistration also here you can go up to 1 pixel. If we compare both, maybe before we can show you a PDF also. So this has to be bought from ISO, that's how it works. I don't remember how much it is. It's the same. You have here it's more simple. I would say you have a text explaining, what is Adobe 98 and so on and so. And the sorry. Yeah, I mean all is here. How is that? Yeah. All the numbers are in an annex. So where you have all the detail. What you should reach, so you will find all the numbers, so you have the number for the dynamic range.
One question.
Yeah.
The ABC level is is comparable to the stars in Fudgy then?
Yeah, would say yes. Yeah. We didn't took star because we didn't want people to make confusion between Fudgy star and ISO star. So that's it. But the idea is the same. To have, so you can see here. For example, if you take the tonal reproduction, A is more difficult to reach than B and more difficult to reach than C. It's always like that. So that means that sea level can be reached by a cheap scanner, I would say. Of course, everybody would like to scan at level A, but sometimes when you buy a scanner, you can say, I want to buy a scanner able to scan Fudgy 3 or 4 star or level A ISO. But if you already have a scanner and you want to check what you are doing, you need also to have a lower level. Or if you scan something that has no real value, and you don't want to spend too much time to check everything, you can say, I will apply level C, and then you can do something. Okay, so here you have all the value. You see the sharpening value here also. Here we go. And you will find it's very close to metamorphose. You find also the same non-uniformity elimination for A0, A2, and A3. Okay, so this is to compare. If you want to compare, it's still difficult because the units are not always the same and so and so. But rapidly, you will see that metamorphose and ISO A are very close. You see for the tonal response, it's the same thing. The gain modulation is very close. The correct accuracy is still difficult because the unit formula is different. But again, this metamorphose will go to that on the next version. The noise, it's difficult to compare because it's visual noise. What you can see here, this Fudgy 4 star is always more difficult to reach than ISO or Fudgy. If you take the other one, you know, Fudgy is 90%, it was 85 plus that. So both make it very difficult. Sharpening we don't mind. Lighting uniformity, this also is not easy to reach. 1%, especially on large scanning area. Because 3L is the same here and it's the same than that. So most of the time, ISO and Fudgy are very similar and they are between 3 and 4 star, I would say. But in Fudgy, you have no, yet today, maybe in the next version, you have no geometric accuracy to check, and you have no gain modulation to check also. Okay, so ISO was published, I think 2 years ago now. Fudgy also, Metamorphose is older, so you will have a next version next year. Fudgy, I don't think you will have a next version very soon because you cannot change every year, all that. It's quite heavy, you know. And ISO, we are doing some small modification, but nothing very important. Any question on this? So you can decide to apply what you want. It doesn't matter, it's the same. I mean, what is important is to check the quality of your production. So you can use any kind of standard to check the scanner before buying it. You can check also any kind of standard to check your scanner in your office before scanning, to check that everything is okay. It doesn't make a big difference if you check Metamorphose, ISO, or Fudgy. Just have to select the right level. So, how to check this now? So we talked already about some charts. So you know these two for color, these two for resolution. So this one here, I mean, probably you know the Kodak chart, it's the old one, but now it's difficult to buy and it's not very good also, not really neutral. So we have this one now from Ansel, which is better. You have one gray level every 5L, so 5, 10, and 15, and it's quite neutral.
Excuse me, how often should you exchange these charts? Because I guess they fade.
Yeah, it depends on the chart. It's difficult to say. On the UTT, I know there is a date at the back written, it should be changed, but it really depends how you use it. UTT can be damaged very fast because it's very thin. The printing is very thin, so it can be damaged. It is more how you use it. If you keep it in a box, in a black box, you can stay several years, no problem.
Several years?
Yeah, but if you have it like this, especially on the daylight, all time, after a few months, it will be gone.
Just use it once a day every morning to check your calibration and then put it back in a black box.
Yeah.
Several years.
Yeah,
Okay.
this is the right way. And under it carefully.
Yeah.
Yeah, of course. After, if you want to check, it's difficult. You need to measure the chart. It's possible. There's some device, a spectrometer to measure the chart, but you need to hit one and to do that properly. Then you can have an idea if your chart is damaged or not. That's the only way. I don't know, if you cannot measure your chart, you have to take care of it. And if you have several charts, you will rapidly see that one is giving different results than the other one. And if not, you give it to someone to be measured. Or you buy a new one every 3 years or something. Just maybe easier. And then you have the universal charts. So this one is a UTT from Metamorphose, which is used for ISO also. And this one is from the US. It's called Golden Thread. And it has, where is it? It has the same idea. You have the slanted edge. You have the pair of line per millimeter. You have some color patches. You have some grayscale. You just have nothing to check the distortion. That's it. So if you want to circulate, and it's a little bit smaller. And both of these charts have a sum up here. That is a chart a little bit smaller than this one, that you could place close to your document and then be able to check everything on each image, which is again more heavy because as we saw, there are some tight specification sometimes, so the chart has to be much better than the specification you want to reach. Most of the time you need a reference file with the chart. It's provided by the manufacturer because between these two charts they are not the same level. You have to be aware of a limitation on the chart. They are not all perfect. The scanner is not perfect, the chart is not perfect, and the analysis software is not perfect. So you have to know when there is a problem, where does it come from? And of course you have to replace sometime the charts. So the Kodak chart cannot be used like this. It's not precise enough, it's not neutral. You need to measure it. So I have a customer using it. Is measuring each patch. This is the L value and A and B value for each patch. And once you know that, you can use it. If not, you cannot get anything from that. It depends too much. You can see that the color is not the same between two patches and so it's very difficult. This one. So this one has a standard reference file. They are supposed to be very close together as long as they are made after November 2014 because they changed the ink at this time. So it's quite good, but you have to be aware of something. this white patch here is not neutral. You can see the value, so it's a file we can get from X-Write on the web. These are the LAB value from the white patch, and you see the A and B are not equal to 0. They should be 0 if it is neutral, and it is 1 and 3, minus 1 and 3. So if you check in RGB, so you have to say in which color space you want to check that. So I selected ECI RGB. The RGB value of this patch should be 243, 243, and 238. So that means there is a 5-level difference on the blue channel. So you should not adjust your white balance on that because it's not white. You have to be aware of the next one is better. This one here, you see it's more neutral. Not perfect, but it's okay. This is a screenshot with the line scan scanner. So you have the grayscale, the black patch up to the white one. You can see that the channels are all three at the same level, but not on this one. And you can see the value here. So these are the value from the camera, the value after file conversion. And you can see the value about the one we have here. That is about up to 5-level difference between red and blue. And it's really visible. So if you try to neutralize that, it will not be good, and then all this will not be good. And all your document will be wrong. The black patch here is quite neutral. It's the same for this one. The white patch, all the white patches here are about the same. They are not really neutral. So you see B is 2. Again, that can make a big difference on the blue channel. Okay. A6. Yeah, you can see that the gray, this is white, this is black. The black you see is neutral, this one here. And the gray here, 50. 50 means that it's L star 50, that is in the middle range. It's again the middle gray, which is here. And this one is quite neutral also. So you can check your white balance on that, but not on this. And the UTT, so this is an A3 UTT, this one. It can go up to A0. Then you have 8 A3 UTT on the same chart. So make a very big chart, difficult to handle, and you will damage it very fast because it's too large. So you need a file giving the value of this gray level and the color chart also. So here there are 4 grayscale. On this one there are 32 grayscale, and they're not the same. So you need a good file. And this is, for example, the file from one chart. So you have the grayscale, it's a left grayscale, so this one. So the white patch, the black patch. These are the values they wanted to reach before making the chart. And these are the real values they get from the chart. So you can see that the white patch is also not neutral, a little bit like the color checker. So A is negative, that means it's a little bit green, and here it's a little bit yellow. So it's a green-yellow. But after that it's better. The third one, is beginning to be neutral. And if you look down, the last patch was supposed to be L3, and in fact it is sometimes higher than the other one. And this can make big problem when you check the gain modulation, which is the slope between two patches. If they have the same level, in the formula you divide by 0, so you can get anything, can be anything. So now we don't check this one anymore. And there is another issue. If you compare these two, for example, you see there are 7 L different between these two patches. It was supposed to be only 5. And somewhere else it will be less, I don't know, but You can have, this one you have only maybe 3 something. So if the distance between the patch are not the same, this will also make problem in the gain modulation measurement. So you have to deal with that. But you cannot work without this reference file. No result. No way. And if you want to measure this chart, if you have the tool, you can check that this value are still right after 2 or 3 years. Maybe easier to buy a new chart. So this is a US chart, so the golden thread, or it is called dice also. So the small one here, it's A4. When you want to check on a larger scanning area, you have this small chart you can put on the corner. And then you can check the resolution here, so in the middle and in the corner. And also the lighting uniformity using this patch here. So you compare the level here with this one, and you check if the lighting is uniform. And to continue with the problem you can have with charts, I bought all these together. So this one is $600, this one is $100, so the total is $1,000. By this, okay? And I tried to make a test, and I could not reach the lighting uniformity. It was wrong all the time. So what I did on this kind of scanner, you know, the lighting is and the camera is moving. So we know we have exactly the same result between here and here, for example, because it's moving. So I put the chart here, and I had about 3 or 4% difference between the levels. And the specification for 5G 4-star is 1%. For 3-star it is 3%. And on the chart I already have more than what was needed for 3-star. So it was impossible to get that. So I called the manufacturer, and he sent me some small patches to stick on my chart, having all the same color, been made at the same time, you know. And then now it's working. So you always have to be careful when you use a chart. Is it precise enough? Sometimes it's not. There is another issue on the UTT. For example, this edge is not sharp enough. If you want to scan 600 dpi, the efficiency will be lower than it is really. For example, if your real efficiency is 85, you will get 80 or 78 or something. So you have to know it. This one is better for that. I mean, if you compare both, this one is this edge is sharper, and the color patches are like the color checker, so they are more stable on light also. But with that, you cannot check the geometry. That's it. And the reference file is here, inside the barcode. So you cannot make a mistake. The analysis software will read that, and it will know which value you have inside. This is a new one, the low-cost one, which is supposed to come probably beginning of next year, I don't know. So it's also inkjet printed, so I don't know about the color, but the idea is to have a low-cost chart to check rapidly and easily the resolution. The Library of Congress also made, with this company, made this chart. So this chart, the idea is to have a chart very robust. You can put your finger on it. You have here a cleaning tool. So it's made to be clean. This chart you can clean. If it's damaged, it's finished. This one you can clean it. And even they clean it several times before delivery, so it's stable. And there are also some specific color for heritage. You know, color you will meet on paper, on things like that. Yeah. So the idea is to build an ICC profile from that, which will be more precise on the color we are scanning. So at the moment, I don't know anyone using that, but maybe it will come. I don't know. So it's possible to get that. Okay. So how to rapidly how to calibrate a scanner. So there are three main calibrations. It depends on the scanner, but it's more or less the same. You have to adjust resolution and focus, especially when you have a camera on a copy stand like this. The resolution depends on the distance between your document and the camera. So here it's free, you can get the level you want, so you have to check which resolution you get. It's what they call the, they call the claim resolution. You say, I'm scanning at 300 dpi, and then you have to check how much dpi you really get. So it's a first test we do in the test. That is, you scan something which is 1 inch, and you count how many pixels you have. We don't mind if the image is sharp or blur, but you say, I'm scanning at 300 dpi, and maybe it is 310. And then you will check the efficiency. But the first step is to check the real resolution. And focus will give the efficiency. Then you have lighting correction or flat fielding to compensate for any light variation on the image. And you have then you have the color and the tone response adjustment. So resolution is, not very difficult to understand. You just get the right distance, you get the right resolution, and you adjust focus. Okay. Lighting correction or flat fielding. Most of the time you will have a darker image on the corner, or it can be on the side if your lighting is not good. Then you will usually scan a white paper, and the software will compensate for the shadow on the edges. On a line scan scanner, it is a little bit easier. You just have to compensate for in this direction because everything is moving. But the idea is the same. The color calibration, so we say color calibration, it includes also the tone scale calibration. So usually you will look at the grayscale of a chart. You have to know which level you should get, and you will do what we call the white balance. So make sure that the red, green, and blue channel are the same level on the white area, taking care if this one is not neutral. And you do the same on the black area. You manage to adjust the three channels so they are the same level. And after that, you adjust the black point and white point. That is, you check that your black level is at the right level. So you need to know the density of the chart and which level you have to reach depending on your color space, on your gamma correction. And the same for the white. The white, you have to know the density, then you can calculate how much you should get. And once this is done, the color should be okay. Here, it's only a grayscale. It's only a grayscale. We don't look at the color patches. The color will come with ICC profile as long as you get the right SC profile. So it can be provided by the manufacturer. For this one, for example, we can provide the ICC profile because the lighting is very strong. It doesn't depend on the ambient light. On this one, it will depend first on the lighting because you can have different lighting. So each time you change the lighting source, you need a new ICC profile. And if you are working in a room with some ambient light which is strong enough to make a difference, you will have to make a new ICC profile also. And then you are ready to make the test. So it's a iterating process. So you scan the chart, you check the result. If needed, so if everything is okay, you can scan. If it's not okay, you may have to adjust a little bit the black level or one color. And if really it's very bad, you may have to build a new ICC profile. So it can be. So you can do that with single charts. This is a setup we have in a customer in Indonesia. They have a white paper with some resolution charts, a grayscale, a color chart. With that, you can check ISO, FAGI, what you want. As long as you can check the lighting uniformity with the white paper, the resolution everywhere, I mean, center in the corner, that's enough. The grayscale and the color accuracy, you have enough. But as they are using a Kodak grayscale, they need to know what are the real value on this chart. And then they have an Excel file, they enter the value of the image, they compare both, and they give the delta L, so the luminance error, and the gain modulation, and they check that all the gray patches are neutral, and so on. So here, when you have a mistake, it is displayed in red or yellow. So it takes time, because you need to run one software. I mean, even it's Excel, so you have to copy the value inside. It takes time. To check, here you will check the tonal scale only. Then you need to use a small chart to measure the resolution. So for this, there is a free software called ImCheck. I have to show this to you in this afternoon. So you just scan the chart, you click here and there, and it gives you the result. So you have the sampling efficiency and the curve, so you can see how it's working. And to check the color, there's several software, but you can use IQ Analyzer from Germany. And it will give you the delta E for all patches. So you can see here, on the border, I have grayscale patches. So usually I have a better result, because you usually spend more time to adjust the grayscale, and it's easier to adjust. So usually you have a low result here, and you have a different delta E on different patches. So here's maximum is 10, which is, I don't know, on patch, maybe the purple one, I don't know. And that means the average delta E is 3, the maximum is 10. That means it is metamorphose compliant. So that's enough. And if I want to know a little bit more, I can just display the delta L on this chart. It is just the luminance error to see if there is something wrong on the luminance. As long as the luminance is wrong, the color will be wrong. So I can get some more information on that. But here I can see it's quite good. I mean, I have 0 on this patch, 0707, so it's okay. And this is using the 76 formula. This setup is for metamorphose. And when you want to use the UTT, so you scan the UTT, you use IQ Analyzer and the UTT module, and you get this result. So as long as you get that means it's okay, you have to scan. If you have something red somewhere, you have to look for what to do. So you have the 6 criteria we see at the beginning. So tonal reproduction, again, it's just you have to be within the green area, okay. Noise. So we see again the dark patches where the noise is higher, and here there is also a dust probably. Okay. Resolution. So resolution, we will see sampling efficiency. That is at 10% contrast. You have the low frequency at 50% contrast. You have this is the max modulation. That is, if the curve is going higher than 1 or not. It's not allowed to go higher than 1 or 5. You have the color misregistration. That is the shift between the color channel. All this is measured on the slanted edge. And that is this and this are the same. So you have all this information. So you can fail because of that, because of this, or because of that. It depends. On the UTT, you can still check the color, even if it's better to do it on the color checker. So here it's the same. You get the delta E for each patch and the average one, and the maximum. The lighting uniformity, the college shading, it is checked on this line here. So at the top, in yellow, you have the horizontal white and gray line here. And at the bottom here, you have the vertical white and gray one. So we'll make the test in the afternoon. You will see what can happen. They have to be straight, and they have to be at the right level. There is another test on the checking the level of the gray and white patches here on the chart. So it's also included in the shading. Yeah, and this is a distortion. So in IQ analysis, there is a problem with the distortion. To check that, they measure the width of the gray and white squares. And in fact, they have a difference between gray and white. So it's going like this. And it is not at all distortion. And that means the result, you cannot rely on this result because of that. So they may change that one day. And at the end, you finish with that. So this is just the resolution numbers from this display. So it's the same, just a real number. So if you want to look, check the number and so. This is a color number. This is a shading number. And these are the number from the grayscale. And you have on one A3 chart, you have 4 grayscales, so 4 tables like this. And if you check an A0 chart, you will have 32 tables like this to check. So it's a little bit frightening, but it works at the end. First, in Metamorphose, they did that in several steps. So they realized it was not always possible to have all the grayscale perfect because there are too much difference between these grayscale. So it's written in the PDF somewhere that you need to have one at least. If you have one grayscale, it's okay. The other one should be okay. But if they are not, you have to look if it comes from the chart or from the scanner. Sometimes you can, for example, rotate your chart, and then you can see if it comes from the chart or from the scanner. And when there is something wrong, you have the number can be displayed in red or yellow, and you have to look what is wrong. So here you have the patch number. You have the reference values. This is the luminance value of all these patches. You have the value you get on your image. This is the difference, so it's a delta L, the tonal response. And after that, you check for each patch if it has the right color, if it is neutral. So you have a delta E value for this patch. They also check the delta C, which is the chrominance, the chroma. And they check the gain modulation, so the slope, and they check also the noise. So this is all these numbers. So you will see in the afternoon what to do when something goes wrong. But that's right, it's not so easy. And at the end, you finish with that, and you're happy. When you want to check the dice chart, it's the same. You have a software going with it, with a sum up. It's the same idea, just the display are different. This is a resolution display, so you get the MTF curve. You don't get with the IQ analyzer. You get the sampling efficiency here, so in DPI again. You get the delta E, so for each color patch you get the delta E value. The lighting uniformity, so in the center, in the corner, what you get and what you should get. The tonal response, so this display is difficult to use. It's better to rely on this one. So this is a grayscale, but it displays just the difference between the chart value. So here I can see that the red channel is too high. Here the red channel is too low on this patch. So it's easier to understand than the display we had in IQ Analyzer. And it is in RGB, so it's not good to measure in RGB, but the advantage is I know directly that if I want to lower this point, I have to lower the red channel. The problem we have here, when I have a delta E which is wrong, I don't know if it's come because of the blue channel, red channel, or green one. So the scanner is still working on RGB, so I need to know what to do on the scanner. So I need to know if this delta E comes because of the blue, red, or green. So I need to look further to open the image with Photoshop and so on. So here I get directly the information. It's a bit easier. And here you get the patch density, so 0 for the white. And you can see the black one go to 2.4 or something. And 1.5, I mean for books, is here. Even in Fadji, they don't make the difference. And this is a free software, OpenDice. So this software is about $1,500, I think. Now you get it for free. So it's a little bit more basic, but it works. At least it works with Color Checker SG and with a dice chart. It's supposed to support the UTT, but it's very difficult to use it for that today, maybe in the future. And so you have the same kind of display. This is delta E display. This is a tonal scale display again. And this is the resolution. So here you can see the limit. You have to go inside. So maybe here, you see it's for, I don't know if it's probably 4 star, I don't know, 3 star. This is for 3 star. The luminance here is probably a little bit too high, I mean the contrast. And you have a sum up and with the real number, so you can see what can go wrong. For example, here, the resolution, I mean the efficiency, I would say, I had to reach 270. They found 400, so that means it's okay. But for the contrast, you know, here, the contrast has to be lower than 0.3, and it was 0.31. That's why it is failing here. And the same for the other one. It's more visible here. And so this is a standard setup, I would say, to check ISO or metamorphose. So UTT, Color Checker SG, IQ Analyzer with the UTT module, and IQ Analyzer with the color module. So 300 euros, 1,700 something, and about the same here. So the total is about 4,000 euro, I think. And for Fadji, so today this is $1,000, and this is free. And in the future, we hope having something about $200 and still free. So it will be cheaper to check Fadji in the next future. Okay, and that's it. I don't know. Yeah, this is the link you can get on the presentation. So this is where to get the Metamorphose guideline. This is to get Fadji guideline plus OpenDice. If you want to download OpenDice, you can get it from here. This is where you can buy the ISO standard. This website is for color. If you want to get some information on color, it's very, very interesting. Just use that to get some information. And this is the website of the manufacturer of the UTT and IQ Analyzer. So Image Engineering in Köln. This is a website for the Golden Thread and the software going with, so it's Don Williams' website. And this one is where you can get ImCheck to check the resolution for free. For free, I mean. You still need to get this chart, which is also about 200 euro. But it is a very good one. And that's it, all I have to say today. So if you have questions, we have time before lunch on all that. What do you think about this? It's too, yeah.
So the evaluation software can only be used with special test targets. So you can't just use any test chart and use it on the software. So it has to be.
Yeah, IQ Analyzer can go. You have the color module, which you will check this or that. With the UTT module, you can check the UTT, of course. With where it is? With OpenDice, you can really use the dice chart, that is this one, and the color checker SG. This one, I mean, I tried this one. It's very difficult to get something today. Maybe they will improve. And with ImCheck, you can very easily use this one. You can also use ImCheck to check only one edge like that. So you could use it to, but it takes more time. You have to select one edge to get the result. You select the other edge, you get the result. It takes more time, but you can, with ImCheck, check any slanted edge. So it can be on the UTT, on this one, on this one. That's how we could find that the edge here is a little bit weak compared to this one.
And the check is same for both
Sorry?
type of scanner, or is it just?
I don't know, check on the image.
Always the same?
You have an image, so you don't know from which scanner it is coming. It can be from your phone camera, it can be, I don't know, don't mind.
So in the afternoon you will show us how to use the targets and use the software.
Exactly, yeah. This afternoon, I mean, I will show you this, all that. I don't get this. I mean, I don't get the software here. I get it on my laptop if you want to see. And we will also use ImCheck because it's very convenient and it's free, so it's very easy to use.
And if anything is wrong, will you also show us how to adjust or calibrate the scanner? So what?
Yeah, exactly.
Yeah, okay.
If it's right the first time, we will do something to get it wrong. Don't worry.
And what is crucial to choose the software? Which one to use?
I would say it depends, you know. If you want to check metamorphose or ISO, you have to get this. You cannot really do without having IQ analyzer today. Because especially ISO, you have some specific formula. You cannot really do. You can do it. I mean, you can do it like they are doing in Indonesia, but where it was, yeah, this one. You can also check with that, but you need ImCheck for that. You need IQ analyzer, or there are some other software to check the color here, and you need something to check the grayscale. So that means it will take more time.
It doesn't matter. I mean,
No. Of course, you will have slightly different results depending on software, because software are not perfect and the formula are not exactly the same inside. But you don't mind. You stick on one software and you make your test. No. This is a basic one. I mean, this could be cheaper, but it will require more time because you need to check the resolution with one software, check the color with another one. The grayscale, if you have no specific software, you have to do it more or less manually. It takes a lot of time. So, no, it's difficult. Really, the best solution is to have that. It's quite expensive, I know, but I mean, we are not making anything of that. This, I like the idea to try to make it as cheap as possible. So we'll see the chart, how it will go, how good it will be. Software, it's a basic one. I mean, you have to click at the right time on the right button. If not, it is. But it works. I mean, when you know how it works, it works. Okay. You know, with that, I've checked FAG 4-star for the nasal scanner. It works. It just, I mean, not so convenient to use, but it was. They will improve it. They promise that they will maintain this software, so until it works correctly, and so once a new chart will be released, I think the software will follow a few months later, probably. And okay, so but this one, I mean, is good. The chart is good. The software is free, so that's good. But it's US, we're in Europe, you know, and people will be more checking metamorphose or ISO because we're in Europe. I mean, we have some European customer using this chart, and I know some US customer using this one also. But mainly in Europe you will check that. And what is good, by the way, it's the same setup for both standards. So you can start with Metamorphose and switch to ISO if you want. It's possible.